Good evening, everyone, and welcome to our live coverage of the latest mission from NASA's Kennedy Space Center. I'm Will Robinson-Smith. I'll be providing our commentary for the duration of this coverage. We're broadcasting from the Spaceflight Now News Bureau here at KSC. Stephen Young, our editor here at Spaceflight Now, is running the technical operations for the broadcast. Adam Bernstein out in the field getting ready to track the rocket and do some still photography as well. Michael Kane has the evening off, but if you'd like to follow either of their accounts on social media, these are their handles on X. They both have some great launch photography up from the prior Falcon 9 launch that happened just a few hours ago, USSF 124, which launched from Cape Canaveral Space Force Station on another Falcon 9 rocket. And in fact, just before we came on live, we did get word from the U.S. Space Force's Space Systems Command that the launch of the 6 satellites for the Missile Defense Agency and the Space Development Agency were deemed a success. These are hypersonic missile tracking satellites launched for those two agencies. This was the 8th launch using a Falcon 9 rocket supporting a national security space launch mission for SpaceX. So, been a busy day for the company as it is preparing for yet another Falcon 9 launch this evening, this time from historic Launch Complex 39A. We're now T-minus 1 hour, 56 minutes, 23 seconds and counting. Tonight we also have tracking views and support from our friends Pete Carsons with Max Q Productions, as well as Chuck Briggs. Historic Launch Complex 39A here at the Kennedy Space Center. Once upon a time, it was built as the moon port, since it served as the gateway to space for crewed Apollo missions launching on board a Saturn V rocket. As you see with the countdown clock here at the press lawn, we're less than 2 hours away from SpaceX attempting to bring back moon missions to this historic pad and launch a Falcon 9 rocket. The first mission heading toward the moon from this particular pad since the Apollo 17 mission back in 1972. No humans on board this particular Falcon 9. We have a robotic lander from Houston-based Intuitive Machines. This particular type of lander is called a Nova C, and this one in particular is Odysseus. It's poised to be the first commercial lunar lander to reach the moon in history if it's able to touch down safely. There have been 3 prior attempts before, one from Israel, one from Japan, and one just last month from here in the United States, Astrobotic's Peregrine lunar lander, which unfortunately had an issue with its propulsion system and was not able to even approach making a moon landing attempt. We'll have a little bit more on that as we continue to step through the count. Now you may be wondering why we're coming on quite so early, about 2 hours prior to the planned liftoff. Reason being, and you can see some of the vapor forming near the base of the Falcon 9 rocket. You may be thinking, well, that seems rather early. However, this is because on board the Falcon 9 rocket, that Intuitive Machines Nova C lander uses a combination of liquid methane and liquid oxygen as its propellant. And given its use of cryogenics, it needs to be fueled as close to launch as possible. So the fueling process begins with the loading of liquid methane about T-minus 3 hours. Now at T-minus 1 hour, 53 minutes, 40 seconds and counting, we're in the process of loading liquid oxygen. And in fact, just seconds ago, we got word from SpaceX that in fact, fueling of the lander is underway, and the weather currently stands at 90% favorable for liftoff. We'll have much more to talk about as it concerns both the lander as well as the mission. Not formally a NASA mission. This is a commercial venture. NASA happens to be a customer on board. Taking a look here, you can see what the spacecraft looks like in this rendering of the Nova C lander on the surface of the moon. Starting to see some vapor there from the transporter erector as LOX load gets underway on the Nova C. SpaceX did a series of modifications to the transporter erector to support the launch of this particular mission. SpaceX's Bill Gerstenmaier says that the changes that were made to be able to do this late fueling process, he described as generic and ones that can be used not just for this particular mission or other landers from Intuitive Machines, but other customers that may require late load cryogenic fueling to open up the marketplace a little bit more for future prospects. So certainly another interesting addition for SpaceX that is now a novel capability, adding to the long legacy here at LC-39A. Coming back to that lander that you see there on the left-hand side of your screen in this rendering, just to give you a sense of scale, because you may be looking at that thinking, well, it could be pretty tall, could be pretty short. Here are those dimensions on that. It's 4.3 meters or 14.1 feet tall. It has a hole diameter of 1.6 meters or 5.2 feet. Those landing legs that you see surrounding the base of the lander extends to about 4.6 meters or 15.1 feet. Of course, we're going to talk much more about this particular spacecraft over the next couple of hours. We're T-minus 1 hour, 50 minutes, 48 seconds and counting. SpaceX is targeting a T0 liftoff time of 1:05 a.m. Eastern Standard Time. For our friends joining from around the world, that's 06:05 UTC. This is an instantaneous launch window. Think of it like a planetary mission, if you will. That launch window lasts just 15 seconds in total. So if, for whatever reason, they're not able to launch today, they have one more day for a launch attempt this month. Otherwise, they'll need to stand down and pivot to the March launch window. Because of the length of February, in fact, the launch window in March is the same as the window this month, the 14th through the 16th. If you'd like to help support our coverage of the space program, there's a quick and easy way to do that. You just click the like button here on this particular stream. Share the stream if you would. That'd be a big help and allow more folks to find this live coverage as we continue on through the count. Also, if you're not already subscribed to Spaceflight Now, we'd love it if you would consider that. And if you do subscribe, be sure to hit that bell icon and make sure you have all notifications turned on here on YouTube. That way you'll be alerted whenever we do start these live streams, as well as post videos here on the channel. We are powered by our wonderful channel members. See a number of them joining us tonight. See Yahweh's Prophetess, Zephyr Wolf, Callistia Lee, that Opal guy, I Am Letta, among several others. So welcome to all of our channel members joining us tonight. Channel membership comes with a number of perks, including discounts at our online shop, shop.spaceflightnow.com, access to member-only videos, as well as, of course, access to 4K views of all the launches from here on Florida's Space Coast. Last but not least, you can also use the YouTube Super Chat feature if you'd like to be a part of the conversation. If you have comments or questions that you'd like to have as part of the broadcast and they're appropriate to be read on the show, we'd love to include those in here. And it also helps support the channel and allow us to increase our technical infrastructure to bring you increasingly better live streams. With all that out of the way, we're about an hour and 10 minutes away from the point at which the launch director will give their go for the start of propellant load for the Falcon 9 rocket. As mentioned, the fueling process a little bit different tonight because the Nova C lander is on board. That began at T-minus 3 hours with the loading of liquid methane. And now starting at T-minus 2 hour mark, they began the process of loading liquid oxygen onto the vehicle. Now, even though this is not formally a NASA mission, because NASA is a customer and does have half of the payload space on board this lander, we should also be getting clean mission audio loops of the countdown in progress. As soon as those becomes available, we will of course bring you those as an element of our broadcast. That being said, once those loops do come into the mix, you may hear me pause so we can get those call-outs from Mission Control and we can all listen in to the relevant updates. SpaceX is running its countdown from its Hangar X site here at the Kennedy Space Center, at the facility where they refurbish Falcon boosters and prepare them for future flights, as is the case with the booster you see here on your screen. Intuitive Machines also has plenty of their staff alongside SpaceX, as they've gone through a number of rehearsals in the process of fueling both the lander and the Falcon 9 rocket in succession. SpaceX also has support for this launch in part from the control room at their headquarters in Hawthorne, California. Once the Nova C lander is separated from the Falcon 9 rocket and on its way to the moon, the teams for Intuitive Machines at what they call Nova Control in Houston will take control of the mission and monitor it as it makes its path to the moon over the next several days, with a plan landing on February 22nd. Again, this launch is targeting a T0 liftoff at 1:05 a.m. Eastern, 06:05 UTC, with just a brief 15-second window for launch. Again, if needed, SpaceX and NASA, as the customer, do have a backup launch opportunity tomorrow as well. As I made a passing mention to it, weather was fairly decent coming into tonight's launch attempt. Meteorologists with the 45th Weather Squadron forecast 90% favorable weather at liftoff. The only watch item is the thick cloud layers rule. Upper level wind shear also listed in the, quote, low to moderate level on the additional risk criteria as part of the forecast, so naturally we'll keep an eye out for that. If needed, the 24-hour backup opportunity decreases a bit to just 80% favorable, with the same additional risk criteria. The winds at liftoff also pick up slightly as well in that 24-hour backup situation. We're now T-minus 1 hour, 43 minutes, 55 seconds and counting. We'll hit the trajectory once this hour, and then again as we cross into the final hour before the planned liftoff, as we get some more folks joining us closer to launch. Of course, the Falcon 9 is launching from LC-39A here at the Kennedy Space Center. For those watching from Central Florida, you're going to be in for another treat once this booster separates. Falcon 9 is going to fly basically due east from the Kennedy Space Center, with that booster returning for our second land landing in several hours. This time, this booster is going to be plunking down over at Landing Zone 1, getting ready to stand beside the booster that launched the USSF 124 mission earlier today. This particular Falcon 9 first stage booster, tail number 1060, is going for its 18th launch to date. Which is why you can see, looking at the live picture on the right-hand side of your screen, why it has as much character as it does. We'll talk about its flight history coming up a little bit later. But the payload fairings, of course, will also be recovered. That's another important part of SpaceX's business model. The recovery vessel Bob is standing by to support this mission. The other vessel, Doug, was in action earlier today, again supporting the USSF 124 mission. The duo were named after the pair that flew on board the Demo 2 mission back in May of 2020, kicking off the crewed side of NASA's Commercial Crew program. Talking about fairing recovery before we go ahead and fully pivot away from this. This is an image of what one of those payload fairings looks like as it's coming down for an ocean splashdown underneath a parachute. SpaceX said in a talk to the company earlier this year that it saves about $6 million per recovery. So just reiterating the importance of this part of their business model. This is an image of one of those fairings being brought aboard a recovery vessel from a launch last year. And earlier this month, the SpaceX Vice President of Falcon Launch Services, John Edwards, noted that they have one fairing half as their flight leader that has flown 15 times, getting ready to make its 16th flight coming up next month. Don't know the exact mission that'll be used for, but hopefully we'll get some more info on that in the coming weeks. Now, in addition to watching this particular launch for its payloads, NASA is also looking forward to tonight's launch because, well, they really need this pad to become open and available again for these fine folks. These are the 4 members of the NASA SpaceX Crew 8 mission that will head over to the International Space Station. That Falcon 9 flight currently targeting liftoff from this pad at 12:49 a.m. Eastern Standard Time. The mission will be commanded by the man you see there second from the right. That is Matthew Dominic, NASA astronaut, class of 2017, nicknamed the Turtles. We're now T-minus 1 hour, 39 minutes, 34 seconds and counting. We're now T minus 1 hour, 35 minutes, 32 seconds and counting. I want to thank a couple more folks for their support this evening. Our thanks to Maria Luisa Medzuzzi for joining us with channel membership at the pad leader level. Really appreciate that. And also want to thank a friend for popping in with some channel support. Delvin, with a very generous $20 super chat. Thank you so much for that. Really appreciate it. With a bit of an inside joke on that super chat. So, made me chuckle. Appreciate it. Thanks, man. As I mentioned, we're T minus 1 hour, 34 minutes, 19 seconds and counting into the fueling process. Now, if you recall, last night's launch attempt was scuttled before we even really got going, as they had an issue with getting the liquid methane chilled to the proper temperature to begin the fueling process, so they weren't able to get things going. But it seems like that issue has been resolved, and we are now well on our way towards completing fueling of the Nova C lander inside the Falcon 9 payload fairings. SpaceX and Intuitive Machines did a pair of what are called wet dress rehearsals on Thursday and Saturday leading up into this process that we're seeing here today, where they've gone and tweaked the timing of the propellant load to find the most ideal sweet spots for the lander. There's about 1,200 kilograms of propellant that will be on board the Nova C lander once it's fully fueled. At that point, it will weigh about 2,030 kilograms. The ratio of LOX, liquid oxygen, to liquid methane is 2.3 to 1. That's according to Intuitive Machines. And to help increase performance of the vehicle, they supercool the propellant. What that means is they bring it down to a temperature of about negative 300 degrees Fahrenheit for the liquid oxygen and about negative 280 degrees for the liquid methane. Taking a quick peek at the live chat. Want to thank a few more folks for their support. Thank you so much, Sausage, for a $2 super chat. Saying thanks to the Vin Scully of SpaceX. You're awesome. Thank you for the support. And apologies to Lita, whose name I've apparently been mispronouncing this entire time. One of our wonderful channel members. So thank you for correcting me, Lita. She adds, thanks for all you do, filling my head with more knowledge. You all rock. Well, it certainly takes a village, and we're continuing to learn as we go here, and we love passing along that learning to all of you. It's one of the great benefits of being a journalist is, as I like to say, you get to talk to a lot of people who are far more interesting than you are and share their stories. We're now T minus 1 hour, 30 minutes, 53 seconds and counting. Now T-minus 1 hour, 29 minutes and counting. Of course, since this is the first time that Intuitive Machines is launching its Nova C lander, they want to make sure that they have all their processes and procedures in a row, if you will. And these are also new capabilities being added to support this lander here at Pad 39A. So on Monday, we had the opportunity to speak with Trent Martin. He's the Vice President of Space Systems with Intuitive Machines. And he was able to walk us through the general fueling timeline for the Nova C lander. Something that they've gone through in simulations and in testing campaigns in Houston before they brought the lander here to Florida, as well as during those two wet dress rehearsal campaigns this past Thursday and Saturday. So here is part of our conversation from earlier this week with Trent Martin.
Based on the testing that we've done, we know pretty accurately how long it takes to fill. So SpaceX gets their LOX and methane systems up and running and at the right temperatures, probably in the L-5 to 4 hours. At L-3, we start the filling procedure, and we'll fill methane first, and we get it full, topped off. Then we start the oxygen and fill liquid oxygen in the system. About an hour before the launch, we're done filling the system, and we have about 20 minutes where we're checking to make sure that we got a good fill, that we're happy with the temperatures, we're happy with the pressures that we're seeing, and we give SpaceX a go for them to fill the Falcon 9. And then they fill the Falcon 9 prior to launch, and then just about 10 minutes or so before launch, we seal up the system and lock it off, and it's ready for launch. It's a choreography that has been rehearsed now a couple of times. The teams are both outstanding teams, so I appreciate all the support we've gotten from the SpaceX team here and from my team here and also back in Houston. The team that's here, that we have here, will travel back to Houston and will operate from Houston once we get into space. But we do have a team here that has been here for, well, some of them as long as a month and a half. And for the team that's here now, that's been doing this filling work and this final checkouts, they've been here for the last couple of weeks, working really, really hard. They're just doing an outstanding job, and they're ready to go.
And again, that was Trent Martin from Intuitive Machines. As far as the fueling of the Falcon 9 rocket, well, that will be par for the course, as we've seen many times, including just earlier today on the USSF 124 mission. We'll note that we are no longer seeing that venting that we've been over the past several minutes during this past half hour. Could be an indication that they are largely through with the LOX load on the Nova C lander, and they're looking at the levels right now. Of course, we'll keep an eye on this whole process, as this is novel for everybody. We don't have a perfectly exact timeline for when exactly things should start and should stop. So we'll be keeping our ear to the ground, and of course, as we hear any updates, we'll be sure to pass them along to you in due course. We're now T-minus 1 hour, 18 minutes, 42 seconds and counting. At this point, Intuitive Machines should be in the final throes of fueling their Nova C lander, wrapping that up in preparation for the beginning of the process for Falcon 9 fueling, which will of course start with the fueling poll at T-minus 38 minutes. And Falcon fueling starts the loading of rocket-grade kerosene on both the first and the second stages of the vehicle, as well as liquid oxygen onto the first stage at T-minus 35 minutes. As we continue to step through the count, I want to thank a few more folks for their support this evening. Lloyd Green, one of our wonderful channel members, with a $4 super chat. Just offering some support. Thank you, Lloyd. I also want to thank two other channel members, Mark Otto and Callistia Lee, for each gifting 10 Spaceflight Now memberships. Really appreciate that, guys. If you're one of those fortunate 20 who are now new channel members here, first off, welcome. Hope you enjoy the perks of channel membership, including live 4K views of this and all the launches from here on Florida's Space Coast. And if you haven't already, be sure to thank them in the live chat. And also thank you to Psychonaut69 for gifting a Spaceflight Now membership as well. Really appreciate that generosity. Another quick and easy way to support what we do here is by hitting the like button if you haven't already. Allow more folks to find our live coverage as we're closing in on an hour ahead of the planned launch of the Intuitive Machines Nova C lander. Now, as I previously mentioned, this is not, in fact, a NASA mission, but NASA is the main customer on this flight. The agency spent nearly $118 million to fly 6 of its scientific instruments on board this lander, and another $11 million to both design and build them. It's part of a NASA initiative called the Commercial Lunar Payload Services Program, or CLPS. If you recall, last month, unfortunately, Astrobotic's Peregrine lander was the first of these CLPS missions to launch. This particular photo was taken on board the lander with a nice view of Earth in the background there. Sadly, it did encounter an issue with its propulsion system and had to end its mission without being able to make an actual landing attempt on the moon. It splashed down in the South Pacific Ocean. Starting to see some venting pick up again there from the transporter erector. Because this is all a new process for those of us on the outside, it's a little hard to tell with absolute certainty that things are continuing to remain perfectly on track, although we We don't have information to suggest the contrary at this point, so until we hear something else, we'll assume that fueling is going according to the fueling timeline established coming out of the Saturday wet dress rehearsal, and that things are on pace for this upcoming launch. Speaking of pace, that was NASA's last mission to launch, the Plankton Aerosol Cloud Ocean Ecosystem spacecraft, which was sent up to a polar orbit to observe the Earth. Going through some early checkouts right now. In the run-up to that mission, we had the opportunity to speak with Dr. Nicola Fox. She's the Associate Administrator for NASA's Science Mission Directorate. We asked her about the agency's thinking when it comes to these CLPS program missions, as we had the unfortunate outcome with the Peregrine lander, and IM coming up tonight. We wanted to gauge how she and NASA are thinking about these opportunities, a different way of lunar exploration for NASA. So again, this is Dr. Nikki Fox with NASA SMD.
We know that the CLPS program comes with risk. It's what I would term a high risk, high reward program. And we've gone from the very beginning saying we expect, or we anticipate, or we're okay with 50% success rate. So we're one in so far, and we've got great hopes for intuitive machines. But if there is an issue, we get lessons learned from, you get lessons learned from every failure. It's something I tell my kids all the time. It's like you actually learn more by failing than you do by being successful sometimes. And so, we're able to just look at all the lessons learned and apply them the same as we do with all our missions, roll everything forward. And so, we wish them Godspeed to the lunar surface. But if it doesn't go totally as planned, we will learn lots and lots of lessons from that, and we know the company will roll that forward into their next lunar lander attempt.
And again, our thanks to Dr. Nikki Fox for sitting down with us and discussing how NASA views the CLPS program. These close-up views of this venting from the strong back coming to us, courtesy of our friend Chuck Briggs, helping to track the launch tonight, assuming they're able to launch this evening. We're now T-minus 1 hour, 10 minutes, 54 seconds away from the planned launch of this IM-1 mission with a Nova Sea lander on board. Closing in on the end of liquid oxygen loading on board the lander, assuming that the timeline is how we believe it is. I want to thank a few more folks for their support as we close in on the 1 hour mark. Nelson Reyes, the very generous $20 super chat. Thank you so much, Nelson. Good to see you back this evening. Says, keep up the great work, Will. Yeah. You are the GOAT of launch coverage. I don't know about that, but I appreciate the high praise. And Callistia Lee with also a very generous $20 super chat. Thanks, Callistia. And I will echo the sentiment here to hit the like/thumbs up button. It's a free and easy way to support the stream and make it easier for others to find. And yes, indeed, if you haven't already, hit the like button. Helps the YouTube algorithm to do its thing and bring more folks into what will hopefully be a launch to the moon tonight. T-minus 1 hour, 8 minutes, 57 seconds and counting. Now, given this is a mission with a lot of NASA science instruments on board, we'd be remiss if we didn't spend a little bit of our broadcast here talking about the payloads on board the Nova Sea lander. We had the opportunity to talk with someone who is very much in the know, NASA's Joel Kearns. He's the Deputy Associate Administrator for the exploration portion of the Science Mission Directorate at NASA. We spoke with him on Monday, and in this part of our conversation, he gives a general overview of the 6 science payloads that are flying on board the IM-1 mission. So again, this is NASA's Joel Kearns.
We have instruments to look at communication and navigation. We have instruments that are going to look at radio frequency astronomy topics, or looking at what's called the photoelectron sheath in the atmosphere, the very tenuous atmosphere on the moon. We've got laser retroreflectors so that once the lander lands at that area in the general South Pole region, we can use our Lunar Reconnaissance Orbiter LOLA experiment, which is a laser experiment, to ping it with a laser beam and find out exactly what its location is. So we have 6 payloads in total that NASA is paying Intuitive Machines to fly in this mission. One of the other interesting ones is one of the payloads is actually built into the lander itself. It's really a high-tech gas gauge method, so that the technologists at NASA can test in a real lunar lander as it flies to the moon and as it descends and lands to the surface, how well can they measure the amount of liquid methane and liquid oxygen actually remaining in the tanks to go down. And that's a really interesting question, because when you're just up in space in microgravity, if you're not propulsively thrusting, you know, the liquid fuel and oxidizer doesn't necessarily go to the bottom of the tank where, say, it would on a car, where you can just pull it into the engine. You have to find a way to get it there, and you have to find a way to know how much do you have left based on what you use, other than just measuring how much you pulled out versus how much you thought you put in originally. So we have 6 really unusual, different experiments that'll gather information either about the journey to the moon itself, the journey down to the surface, or actually look at the environment of the moon itself when they get to that South Pole region.
And again, our thanks to Joel Kearns for talking about those 6 science instruments that are on board the Intuitive Machines Nova Sea lander. We're now T-minus 1 hour, 6 minutes, 17 seconds and counting to the planned launch of this mission, heading to the South Pole. This will be a first for NASA and its robotic landers. And again, this is set to be the first commercial lander to ever successfully touch down on the moon's surface, if it is able to accomplish that very tall feat. Landing set for February 22nd. We're now T-minus 1 hour, 4 minutes, 37 seconds and counting. Taking a look at a view from the pad there at Launch Complex 39A, as we're starting to get access to the technical loops. So as we hear those callouts, we'll be sure to try and pause our commentary so we're not stepping over important updates on this mission. So if you hear me abruptly stop what I'm saying, perhaps mid-sentence, that's the reason why. Want to make sure that we all hear those key callouts as they come about. this Nova C lander mission is just the first for Intuitive Machines, hence the name IM-1. They also have another mission that is currently in the date planning part of the process. They're refining exactly where they want the IM-2 mission to set down on the moon's surface, and that will help drive the timeline for when that launch is set to happen. But look for that toward the end of 2024. And this is, of course, not the only CLPS mission that is on tap for this calendar year. On the back end of the year, Astrobotic will be back in action, set to launch NASA's Viper rover, which will look for signs and evidence of frozen water ice in the moon's south pole. That's set to launch at the end of the calendar year. And Firefly, also with its Blue Ghost lander, is set to launch later this year as well. Now, T-minus 1 hour, 2 minutes, 9 seconds and counting. We do also have confirmation from the Brevard County Emergency Management Office, the agency that activates whenever we are in the process of getting towards a launch. And they have activated their launch operations support team, which of course is a good sign that things are continuing to move on track for this historic launch, getting ready to lift off from Historic Launch Complex 39A in just over 1 hour. Taking a quick peek at the live chat, want to thank one of our wonderful channel members, Wicked Code, for gifting 5 Spaceflight Now memberships. Really appreciate that, Wicked. Thanks so much for the generosity, and to those who are now our new channel members, welcome aboard. And hope you take advantage of the 4K live views of this launch. And go ahead and cast this stream to a TV near you. And kick back and enjoy as we get ready to see the launch of a Falcon 9 rocket coming up in just about 1 hour. And to help more folks join our live coverage, if you haven't already, be sure to hit the like button and share the stream. And we are now less than 1 hour away from the planned launch of Intuitive Machines' first attempt to send its Nova C lander on its way to the moon. And as we are now less than 60 minutes away, let's go ahead and do a bit of a soft reset, welcome in some of the folks that may be joining us for the first time this live coverage. I'm Will Robinson Smith. You're watching Spaceflight Now's coverage of the IM-1 mission. This is the second flight as part of NASA's Commercial Lunar Payload Services, or CLPS program. A program that will see NASA science experiments and instruments launch not on a NASA-built lander, but on commercially built landers, such as the one set to lift off on board this Falcon 9 rocket at the heart of Launch Complex 39A. Sitting inside the payload fairings, it has completed about 2 hours worth of fueling. Part of the process required, as it is powered by a combination of liquid methane and liquid oxygen. Cryogenics that require late fueling ahead of its planned launch. This particular lander is going to be heading to the moon's south pole region, just about 10 degrees north of the South Pole. The farthest south that any lander from the United States or any other country has explored to date. An important forward step as we prepare to send humans to the South Pole through the Artemis program. It'll still be a while yet before humans put boots back on the moon, but in the run-up to that, a series of robotic missions are set to explore our satellite above in a variety of regions. CLPS providers include, of course, Pittsburgh's Astrobotic, Houston's Intuitive Machines, as well as Firefly Aerospace. Our T-minus 57 minutes, 36 seconds and counting. Less than 20 minutes now to the point in which the SpaceX launch director will take the pole on the start of propellant load for this mission. The lander is now fueled, and we're stepping into the final process of just getting the Falcon 9 fueled up and ready to launch. And this is the spacecraft getting ready for its first lunar excursion. This is the Nova C lander. This particular one that's getting ready to launch tonight is called Odysseus, or Odie, if you ask some of the folks from Intuitive Machines. It stands about 4.3 meters or 14.1 feet tall. It has a hull diameter of 1.6 meters or 5.2 feet. With the landing gear extended, that has a diameter of about 4.6 meters or 15.1 feet. If it is able to launch today, or if it needs to wait to launch tomorrow, this lander is set to touch down on the lunar surface on February 22nd. Intuitive Machines says one of the benefits of its propulsion system powered by liquid methane and LOX is that it does not require multiple Earth orbits in order to head out to the moon. They could basically take a straight shot out to the moon and set up its process for landing. We'll go a little bit more into that landing procedure in just a little bit. If you weren't with us this last hour, let's go ahead and talk about the trajectory of this particular Falcon 9 rocket, launching from Launch Complex 39A. It will essentially fly straight out east over the Atlantic Ocean after it leaves the pad. And if you are in the Central Florida area, in for another treat, as we do have another return to landing site landing. This time, the Falcon 9 first stage booster, tail number 1060 in the SpaceX fleet, going to be touching down over at Landing Zone 1. Landing Zone 2 was in action earlier today, receiving the booster that launched the USSF 124 mission. So getting full over at the landing zones over at Cape Canaveral Space Force Station. A good problem to have if you're SpaceX. Following stage separation, the upper stage will continue on. The payload fairings will jettison under some parachutes and splash down in the Atlantic Ocean, as you see in this picture from a previous launch. An important part of SpaceX's business model is it saves them about $6 million with each fairing recovery. And this is just a beauty shot of bringing those fairings on board at a picturesque sunset. We're now T-minus 53 minutes, 57 seconds and counting. On board the Nova C lander is a suite of NASA instruments, 6 in total, that are part of NASA's Commercial Lunar Payload Services CLPS program. NASA paid just under $118 million to have these instruments on board this Nova C lander flight. Makes up half of the total payloads on board this particular mission. As we continue to step through the count, I want to give you an opportunity to see what they look like up close and talk a little bit about them as we get ready for the call out for the start of fueling coming up at T-minus 38 minutes. This first instrument you see here, it's near the top of the lander itself. This is the Lunar Node 1 Navigation Demonstrator, or LN1. It's about the size of a 1U CubeSat. As the name suggests, part of the navigation and communication systems for this particular lander. This instrument was designed up in Huntsville, Alabama, the north end of the state, just south of Tennessee, at NASA's Marshall Space Flight Center. Moving on down, there's a passive instrument that's actually on board multiple CLPS landers. You may have seen this or remember it from our coverage of the Peregrine Mission 1 launch. This is the Laser Retroreflector Array. Again, it's a passive instrument, so it doesn't actually have any active pieces to it, but its point is that it will act as sort of a beacon for other incoming spacecraft that will allow pinpoint location of this and other landers on the moon's surface to keep a sense of where everything is for visiting spacecraft. This instrument was designed from the folks over at NASA's Goddard Space Flight Center. Moving on down, we have the Navigation Doppler LiDAR for Precise Velocity and Range Sensing, or the NDL. Now, for future missions for Intuitive Machines, they will have their own LiDAR system that will allow for increasingly precise landings on the moon's surface. This one is going to be doing a similar function, helping to intake and, in theory, make adjustments on the landing position of the Nova C lander as it's making its descent down towards the moon's surface. However, this one is a technology demonstration. It will not be in the loops, so to speak, making decisions for the Intuitive Machines team, but this will be a good learning process for everyone, folks at NASA as well as Intuitive Machines, on making these pinpoint landings, which will become increasingly important, especially as the expectations for researchers becomes more precise on future missions. I should mention that NDL instrument was from NASA's Langley Research Center. Moving on to the radio frequency mass gauge. This is a nifty bit of technology that you really can't see from the outside, which is why we have this sort of transparent graphic here from NASA. This one developed at NASA's Glenn Research Center. It essentially allows them to use radio waves to measure the amount of propellant in the Nova C lander as it's moving around in a low gravity environment on its way to the moon's surface. When it's both on the moon as well as here on Earth, there's a bit of a pull of the propellant towards the bottom of the tanks, and so they're able to use temperature sensors that go all the way up the propellant tanks to gauge the amount of fuel. That's part of the way that they measure the amount of propellant left. But this will also give them another more accurate way, especially as the spacecraft is in transit to the moon, to know exactly how much fuel is left on board. Moving on, bit of a mouthful here. This is the radio wave observations at the lunar surface of the photoelectron sheath, or ROLSes. Described as a combination of 4 antennas and a low-frequency radio receiver that will study the radio energy environment near the lunar surface. This particular instrument brought to us also by NASA's Goddard Space Flight Center. And finally, one that will be increasingly helpful for a number of landers coming down the pike. This is the Stereo Cameras for Lunar Plume Surface Studies, or SCALPS. It's a series of 4 cameras like the one you see on the left-hand side of your screen. And you may be wondering, what is that gelatinous mass in between the camera and the live picture of the rocket? Well, what this is designed to do is basically take a series of images as the lander is descending towards the moon's surface. And once it's down on the surface of the moon, it'll continue to take images, and they'll collect them all, send them back to Earth, and they'll create this 3D reconstruction of the plume and the regolith, or the lunar soil, that is jettisoned away from the lander as it's making its descent. And that'll help create better models for NASA and for future commercial and government landers to better understand the impact of landing on the moon's surface and what steps may be needed to help mitigate that and create potentially some landing platforms as we continue to see the build out of the lunar economy. So those are the 6 instruments that are part of NASA's Commercial Lunar Payload Services program. Look forward to seeing them operating on the moon's surface, assuming that Intuitive Machines will be successful in bringing them there. We're now T-minus 46 minutes and counting. T-minus 45 minutes, 16 seconds and counting. I want to thank a few more folks for their support as we continue to step on through the count. I want to thank Mark Asada for $10 super chat. Really, thank you so much for that. One of our wonderful channel members. Who continues to spread the generosity and says thank you to Wicked Code for the gifts, referring back to Wicked Code's gift of 5 Spaceflight Now memberships just a little bit ago. Our thanks also to Mark Irish for a $10 super chat. Thank you so much, Mark. And Psychonaut69 for gifting another Spaceflight Now membership. Really appreciate that, Psychonaut. If you haven't already, as we come into the last 45 minutes of the count, we appreciate it if you hit the like button and allow more folks to find this coverage as we get closer to the point of the beginning of fueling on this Falcon 9 rocket, with the first stage booster preparing to launch for an 18th time. T minus 42 minutes, 54 seconds and counting. Taking a very close-up look here at the Falcon 9 payload fairings. A lot of work was done on the system here at Launch Complex 39A to support this launch. New capabilities brought on board to allow for late fueling of the Nova C lander using a combination of liquid methane and liquid oxygen. This is a new capability that SpaceX says is what it describes as generic, meaning that it can apply not only to the Nova C lander, but also to future missions that need late-stage cryogenic fueling. T minus 39 minutes, 50 seconds and counting. A little less than 2 minutes away from the point in which the SpaceX launch director will make the call on the start of propellant load tonight.
All for propellant load is complete. We are go for propellant loading and launch.
Well, I may have actually spoken too soon. We just heard that call out that they are ready now to begin fueling the Falcon 9 rocket, a process that will start in less than 3 minutes. So as we are now ready to step into that part of the process, let's go ahead and take a look at what's to come in the fueling timeline for the Falcon 9 rocket. As we just heard the call out from the SpaceX launch director, we are go for prop load. The process begins at T-minus 35 minutes with a pair of items. Rocket-grade kerosene, or RP1, is loaded onto both the first and the second stages of the vehicle. At the same time, liquid oxygen is loaded on board the first stage. T-minus 30 minutes, the first stage cryogenic helium begins. Cryogenic helium is important because it's loaded onto the pressure vessels on the first stage. It helps pressurize the main propellant tanks during flight. That process begins on the second stage of the Falcon 9 rocket at T-minus 26 minutes. T-minus 23 minutes, the second stage kerosene tank should be full. In a T-minus 20 minutes and 50 seconds, the strong back chill down process begins. We'll see the so-called big vent from the vehicle. Good visual indication that fueling is on track. T-minus 16 minutes, the second stage liquid oxygen loading will begin. That's followed at T-minus 7 minutes when the chill down of the 9 Merlin engines gets underway. That involves flowing a small amount of liquid oxygen through the plumbing and the turbo pumps, and it helps protect those engines from the risk of thermal shock and damage during the startup sequence. About 6 minutes out, the first stage kerosene tank should be full. Then at T-minus 4 minutes and 30 seconds, the strong back retract sequence begins. It starts with the clamp arms underneath the payload
Falcon
fairings.
9 tanks are venting for the start of propellant load.
Those clamp arms open up. Then the strong back will recline about 1.5 degrees away from the rocket. Stays.
The LD briefing the abort instructions. For non-urgent no-go conditions, brief the CE or LD and they will approve aborting the count. For urgent issues affecting the safety of the operation, operators shall call hold, hold, hold on the countdown net. Launch control will abort the launch auto sequence immediately and proceed into launch abort. At T-minus 10 seconds, launch control will be hands-off and relying on automated abort criteria for the remainder of the count.
And there you just heard the SpaceX teams going over the standard abort procedures in the event that an abort is necessary. Again, just so no one thinks that something's happening that hasn't happened. That was not a call for an abort. That was just going over the process of how that would go. Coming back to the fueling timeline, T-minus 3 minutes, the first stage liquid oxygen loading should be complete. It's followed up at T-minus 2 minutes when the second stage liquid oxygen load has wrapped up. At that point, the Falcon 9 rocket is fully loaded with 1 million pounds of propellant. In the final 60 seconds, control of the countdown is handed over from the ground sequencer to the Falcon 9's onboard flight computers. The propellant tanks are brought up to flight pressure. T-minus 45 seconds, the SpaceX launch director will give the go for launch. The engine ignition command will be issued at T-minus 3 seconds. And then if all 9 engines ignite and are healthy, the flight computer will give the command for the hold down clamps to release the Falcon 9 T0 liftoff, again targeting 1:05 a.m.
The launch auto sequence has started.
And with that call out, fueling has officially begun. T-minus 31 minutes, 31 seconds and counting. You can see from this view from our friend Chuck Briggs, some of the venting there in the base of the strong back, some vapors forming as we continue the fueling process on the Falcon 9 rocket. And some interesting bit to note as SpaceX describes this first time that they are loading liquid methane not onto the Falcon 9 rocket itself, but using the Falcon support infrastructure. They say because this is a first, they actually leaned on the expertise from their Starship team to prepare for this mission. So a nice bit of synergy between the teams normally working out at Starbase on SpaceX's super heavy lift Starship rocket and the Falcon team. Great to see the partnership to make a mission like this come together. We're now T-minus 30 minutes, 8 seconds and counting. In the run-up to this mission, we spoke with Trent Martin, who's the Vice President of Space Systems for Intuitive Machines, and discussed the process of actually getting the Nova C lander to the lunar surface. Want to go ahead and bring you part of our conversation of how this Nova C lander will fly and what its path to the moon looks like. So this is Trent Martin with Intuitive Machines.
Just after spacecraft set, about 90 seconds or so afterwards, we turn the vehicle on, acquire our first comm from the vehicle, figure out exactly what orientation we're in, and get into the right orientation. Within a few hours, we actually do an initial checkout of our rocket engine. We do a test fire in space with the rocket engine. We then do multiple trajectory burns to slightly update our trajectory on the way to the moon. Our operations team is in Houston in what we call our Nova Control. Nova Control is made up of a team of engineers and operations folks that have been instrumental in the development of the spacecraft, so they know the spacecraft intimately, to the point that if we see data, we're going to know exactly what is happening because we've seen it on the spacecraft when it was here on the ground. As we make adjustments along the way, we do a couple trajectory burns. We may or may not do those depending on whether or not we need them. You get to the point where you're just about to go into orbit around the moon. That one you can't miss. So you have to fire that one at just the right time so that you can go into a low lunar orbit at about 100 kilometers above the surface. We will stay in that orbit for about 24 hours, waiting for just the right moment where we can begin our burn to fire down to the surface. Once we begin that burn, we do not turn off the rocket engine. It stays lit the entire time all the way to the surface. We do have the ability to adjust the thrust on our vehicle, so we can actually throttle down from our 100% burn down to almost 20-25% of the overall thrust as we get closer and closer to the surface. Essentially, the spacecraft is just slowing down on its way down to the surface, slowing down. Just as we get to where we want to land, we do a maneuver where we pitch and go straight down, and we fire a rocket engine all the way down to the surface. Of course, our optical nav systems are looking, and this entire process happens autonomously. So the vehicle is looking down. It's comparing to known features that we're going to see on the moon, known craters or mountains or just features. And then as we get closer and closer, the system will take over that is looking for the safest landing site within the zone that we've picked. So we will identify the smoothest landing site and we'll land at that smoothest landing site. We obviously have a picked point, and if that site looks good, we'll land there. If not, we'll move to one of multiple sites nearby and land at that site. We land at about 1 meter per second. Once we touch down, the engine shuts off, the vehicle is safed. At some point, we actually vent out any remaining fuel, and then we're ready to begin operations.
And thanks to Trent Martin for walking us through the process and procedure for bringing the Nova Sea lander Odysseus down to the moon's surface. Again, the landing will actually take place on February 22nd, and that will be live streamed, so we'll be sure to cover that. Look for that coming up next week. The engine that powers the main propulsion system on the Nova Sea lander is one they've really put through its paces. Largely 3D printed. It has gone through dozens and dozens of test firings, both in isolation as well as part of the Nova Sea lander itself. They've gone through about 40 different versions of this particular engine, getting it through the process in sort of an iterative development procedure. And so for as much as confidence can be had in this particular propulsion system, they are fairly confident that it will work as designed. One of the key tests will come about 18 hours after liftoff and spacecraft separation. It's called a commissioning burn. It's where they do somewhat short but important burn of the engine, since it'll be the first time that it is operating in the vacuum of space. And that'll ensure that everything is actually running as intended. We're now T-minus 24 minutes, 5 seconds and counting. At this point, the cryogenic helium has been loaded on board the first stage of the rocket, and they've started the process on the second stage of the vehicle as well. No T-minus 22 minutes and counting. Want to thank a few more folks for their support before we hit the so-called big vent here. Thanks to Nancy Barrios for a $5 super chat. Thank you so much, Nancy. Thanks also to Dave Hardy for a very generous $25 super chat. Thank you so much for that, Dave. Thanking us for our coverage here. I also want to thank Silver Ghost for a $20 super chat. Also sharing some appreciation for the coverage tonight. That additional hissing noise you're hearing is the venting at the pad. That is very much intentional. So we're about to see the start of the big vent here. And there we go.
Stage 2 RP1 load is complete.
And you hear that fueling call out there. That combined with the big vent, both good signs that things are continuing on track tonight. Now T-minus 18 minutes, 16 seconds and counting. As the big vent rolls on, let's go ahead and talk about the history of this particular booster as it is launching for an 18th time on this flight. So lots to discuss with the booster tail number B1060. So let's get rolling. Things began back on June 30th, 2020 with the launch of the GPS-3 Space Vehicle 03 satellite. These particular GPS satellites are manufactured by Lockheed Martin and are named after famous explorers. This particular one was nicknamed Matthew Henson in honor of the first African-American Arctic explorer who was part of the Perry expeditions. Next two launches on this booster were on September 3rd and October 24th in 2020, supporting Starlink missions with version 1 satellites. As you see on the screen, they were L11 and L14. The fourth mission came on January 8th, 2021, when this booster launched the Turksat 5A satellite. That was followed by a trio of Starlink satellite missions, L18 on February 4th, L22nd on March 24th, and L24 on April 29th. The eighth launch of this booster was the Transporter 2 mission. It marked the 100th Falcon recovery attempt and the 88th successful Falcon 9 recovery. There were 85 payloads on board this ride-share mission. That was followed up by 5 more Starlink flights after that, starting with Starlink 4-3 on December 2nd, 2021, 4-6 on January 19th.
Stage 2 LOX load has started.
You heard that call out for stage 2 LOX load beginning as the big vent is wrapping up there on your screen. This is the final part of the fueling process that had yet to begin, now underway. Starlink 4-14 mission came up on April 21st, 4-19 on June 17th. The 14th launch of this booster came on October 8th, 2022, when it launched the Galaxy 33 and 34 satellites for communications company Intelsat. It was part of the company's fleet refresh. The 15th flight came on January 3rd of 2023, supporting another transporter mission, this time the Transporter 6 rideshare flight. And there were 114 spacecraft on board. That was followed up by the Starlink 5-15 mission on July 16th of 2023. And the Starlink 6-18 mission, the most recent flight, back on September 24th. Of course, we're preparing to see the next flight, number 18 of this particular booster, supporting the all-important Nova C lander inside these payload fairings. Getting ready to launch now in less than 15 minutes. We're now T-minus 13 minutes, 53 seconds and counting. I want to thank a few more folks for their support this evening as we continue to roll through our live coverage. Jeremy Ladd joining us again this evening with a $2 super chat, saying it's unfortunately too cold on his roof there in Cocoa. Well, fortunately, you can head inside until the point at which we're ready to launch, and we'll be sure to walk you through the count, Jeremy. Drew McFarland with a gift of a Spaceflight Now membership. Thank you so much, Drew. And Marcus Gallegos also gifting 5 Spaceflight Now memberships. So if you're one of those 6 who received channel membership, welcome aboard. Hope you enjoy the 4K views of this and all future launches from the Cape, as well as access to our member-only videos and discounts at our online shop, shop.spaceflightnow.com. And a couple of other super chats from Marcus. Really appreciate that. And sounds like the feed quality issue is able to be resolved for you. So yeah, sometimes a good refresh is all that it needs. Sort of virtual unplug it and plug it back in, if you will. Also want to welcome Billy Bob, our newest channel member, joining us at the mission specialist level. One of our current channel members, United Nations, joining us with a $5 super chat. And I will second that. Let's hope it does not get scrubbed. So far, so good, though, on this flight. And Space Nerd, been a member for 3 months at the pal leader level, who says, 3 months of an epic community? Heck yeah. Seriously, though, thanks to all of you at Spaceflight Now for the coverage. Go SpaceX, go Falcon 9, go Nova C. And finally, for now, Eric DeVille with a $5 super chat, wishing he lived on the moon. I'm sure there's a lot of folks in the audience who would certainly love to visit the moon. Not sure about actually living properly on it, though. But one of the points of this mission and the others in the CLPS program are to test and prove different technologies and gather more science as NASA and its partners look towards creating a sustainable lunar presence. And this goes a long way towards that. As I mentioned just a little bit ago, SpaceX helped this mission along by bringing in some of their team over at Starbase, since they were adding methane fueling now as a new capability at Launch Complex 39A. So a bit of synergy across SpaceX facilities. And they also noted on X that the lessons learned with the Nova C lander will also go towards helping them learn more about necessary steps as they develop their Starship rocket as a human landing system, way to bring humans back down to the moon's surface for the first time since the late 70s, or the early 70s, I should say, more than 50 years ago. We're now T-minus 10 minutes, 14 seconds and counting. As we come into the final 10 minutes of the count, if you haven't already, we'd certainly appreciate it if you hit the like button and share the stream, allow more folks to find this live coverage as we get closer to this historic launch, the second for NASA's commercial lunar payload services program, and what is poised to be the first commercial lander that could be the one to successfully land on the moon for the first time as a non-government built lander.
Spacecraft is go for launch.
And you heard that great call out there that the spacecraft is now ready for launch. As you heard a little bit earlier in the program, that in the final 10 minutes, right about this time, was when they were going to be doing their final checkouts and making sure everything was in the right configuration for the lander. And we heard the call out that they are ready to go. Now we're just waiting on the rocket itself. Now coming into the final 8.5 minutes of the count. This is poised to be SpaceX's 299th Falcon 9 launch to date. Once that first stage booster separates and returns for a land landing, it'll mark the 37th time a booster has touched down at LZ-1 over at Cape Canaveral Space Force Station, the 273rd Falcon booster landing to date. We'll go over some of the other mission stats once this launch is successfully in the books. But let's not get ahead of ourselves here. Coming up, the next fueling milestone is the chill down of the 9 Merlin engines at the base, the Falcon 9 rocket. That's coming up in about 40-ish seconds.
Engine chill has started.
There we hear the call that the conditioning of those 9 Merlin engines is now in work. I want to thank a few more folks for their support as we get ready to come into the final minutes of the countdown here. Thank Buck Burton for a $5 super chat. Thank you so much, Buck. Some of our channel members pitching in with some additional generosity. Josh King with a very generous $20 super chat saying, go IM1.
Stage 1 RP1 load is complete.
please reach the moon. We hear the call out there that stage 1 RP-1 load is complete. First stage now fully loaded with all of its rocket-grade kerosene. Another check mark in the fueling box. Another channel member, Alan Gable, also a very generous $20 super chat. Thank you so much, Alan. Who says simply, to the moon with spaceflight now. A better way to go, right? $2 super chat here from United Nations, asking if we're going to have coverage of the Crew 7 splashdown. We will certainly be covering it. I don't know right this second in what capacity. We'll have those conversations as we get a little bit closer to that, but be sure to keep an eye out here on our YouTube channel and our website, as we'll have more updates on that as we get closer to the return of Crew 7 following the launch of Crew 8. Now, T-minus 5 minutes, 12 seconds and counting.
Falcon 9 tanks are pressing for strongback retract.
You hear that call out? The strongback retract sequence is about to begin in just a matter of seconds. It'll start with the clamp arms opening up underneath the Falcon 9 payload fairings, and then the transporter erector will recline about 1.5 degrees away from the rocket. Stays in that position till liftoff. At that point, it'll pull back in a much more rapid fashion. Want to think
Strongback retract in progress.
And there you hear the call out. We'll see those clamp arms opening up momentarily. There you see those arms opening up. I want to thank Thomas for a $2 super chat. Want to welcome Drew McFarland to channel membership at the pad leader level. Good timing, as now you'll be able to watch this and all of our other Cape-based launches in 4K. One of our fantastic moderators, Astro Joe, been a member for 19 months. Really appreciate you being with us, Astro Joe, who says, thanks for the great coverage, as always. April Mathis Thomas with a $2 super chat, saying, can I see it from Daytona Beach 20 stories up? Possibly, if it's not too overcast where you are. I think based on the trajectory, you may be able to see it from Daytona Beach. That's not too far away.
Stage 1 lock load is complete.
Here the call out. Stage 1 LOX load has wrapped up. Now we're just waiting on Stage 2 to complete. And then the Falcon 9 will be fully fueled. Just a couple more folks to thank real quick here. Get for a couple of $5 super chats here. Thank you so much. And to James Anderson for a very generous $20 super chat saying, yay, rocket launch. And yes, we are just a little over 2 minutes away from this historic launch of the Nova Sea lander. Potentially setting up for the first commercial lander to reach the moon ever successfully. And the first time an American lander is returning to the moon in decades.
Stage 2 lock load is complete.
Hear that call out? The Falcon 9 rocket is now fully fueled with 1 million pounds of propellant.
Ground gas closeouts.
With a call for ground gas closeouts, they're clearing those feed lines. As we're coming into the final minute, we'd certainly appreciate it if you hit the like button, allow more folks to find this coverage as we come into the final 60 seconds before liftoff. We're now 1 minute to launch.
Falcon 9 is in startup.
I'm going to call the vehicle is now in startup. Coming up on the launch directors.
LD, go for launch.
There's that call. We are ready to send this Falcon 9 on its way, coming up in just over 30 seconds.
Thirty seconds.
20 seconds. 15 seconds. And here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Entering ignition and liftoff. Liftoff of the Falcon 9 rocket, supporting a Nova C lander for the very first time. The rocket has cleared the tower. Odysseus now soaring high above Florida's Space Coast on its way to reach the moon's south pole. Let's listen to the roar of those 9 Merlin engines.
Mach 1.
Falcon 9 rocket passing through some thin clouds as it's reached Mach 1.
Max Q.
Rocket now passing through Max Q, the point of greatest aerodynamic pressure on the vehicle.
MVAC chill has started.
With the call out for MVAC chill down, they're now thermally conditioning the vacuum engine on the second stage before it is needed to fire. Get some great views here from Pete Carson's with Max Q Productions. And this view from Chuck Briggs. Now coming up on 2 minutes into flight. Few milestones coming up in rapid succession. We'll start with MECO, main engine cutoff at 2 minutes and 14 seconds. That'll be followed by stage separation 3 seconds later. The Merlin vacuum engine will start at T plus 2 minutes 25 seconds. That'll be followed by the start of the boost back burn and fairing deployment.
Main engine cutoff.
There you see MECO.
Stage separation confirmed.
Stage separation. And the ignition of the Merlin vacuum
MVAC
engine.
ignition.
Stage 1 boost back startup.
And the boost back startup with some brilliant color. And a great nebula effect. Look at that. These views from our friend Pete Carson's. Now coming up on 3 minutes into flight. This boost back burn set to last another just under 20 seconds.
Fairing separation confirmed.
At the call for fairing separation, you see the Nova C lander now exposed to the vacuum of space for the very first time. A very exciting moment, I'm sure, for the folks at Intuitive Machines that have worked hard for years to get to this point. With the call that the boost back burn has
Both vehicles are on nominal trajectories.
completed. And there's a nominal trajectory for both vehicles, both the first and the second stages of the Falcon 9 rocket. Coming up now on 4 minutes into flight. Still some great views from the ground of the Falcon 9 second stage. This from Pete Karstens. Next event coming up is at T plus 6 minutes and 11 seconds when the first stage entry burn will begin. Taking a look here at onboard camera views from the Falcon 9 second stage as that Merlin vacuum engine continues to burn, powering on the Nova C lander. So far, everything proceeding nominally with this mission as we pass the 5-minute mark into flight. Coming up now in less than a minute, the first stage entry burn will begin at T plus 6 minutes 11 seconds. That burn lasting just 11 seconds. That'll set up the landing burn at T plus 7 minutes and 17 seconds.
Stage 1 entry burn startup.
Coming up on the start of the entry burn here. So we've got it in the tracker. Is our Adam Bernstein first eyes on it? So the end of that entry burn.
Shut down. Stage 1 FTSO saved.
Both vehicles are on nominal trajectories.
We have the call out that the flight path of both the first and the second stages remains nominal and on course as planned. We're coming up on the start of the landing burn in just about 20 seconds. As we continue to see onboard camera views of the second stage, the Merlin vacuum engine. Or the call out that the Falcon 9 first stage is transonic, meaning it is slowed to below the speed of sound as Florida starts to come into view.
Stage 2 is on terminal guidance.
Stage 2 FTSO saved.
That landing burn in process. See the landing pad now in view. And the Falcon 9 first stage, tail number 1060,
Stage 1 landing confirmed.
is safely on the ground again. Just a very brief glimpse seeing that milestone.
AVAC shut down. Nominal orbit insertion.
With a call for nominal orbit insertion as the Falcon 9 second stage is entering into coast phase here. That'll last about 30 or so minutes. Setting up for the burn of the second stage engine once again at T plus 41 minutes and 40 seconds. That burn lasting until T plus 42 minutes and 33 seconds. setting up for the spacecraft to deploy at T plus 48 minutes and 24 seconds. We're now T plus 12 minutes, 52 seconds and counting. Take a look on your screen at the telemetry data, the flight path of the stage 2 of the Falcon 9 rocket as it's continuing to coast over the Atlantic Ocean, heading towards the western tip of Africa. Again, the second stage is going to continue to coast along now until T plus 41 minutes and 40 seconds, when there will be another burn of the second stage Merlin vacuum engine, preparing for the separation of the Intuitive Machines Nova C lander. Want to thank a few more folks for their support as we continue to track this very important mission for not only Intuitive Machines, but also for NASA as one of the main customers on board. I want to thank Julie Harland for gifting a Spaceflight Now membership. Thank you so much, Judy. Appreciate that generosity. I want to thank Catherine for 100 Swedish krona super chat. Wishing good luck to everyone with Intuitive Machines and SpaceX, and perhaps us as well. Channel member Nelson Reyes with another generous $20 super chat, saying that footage deserved another super chat. Wow. We'll agree. The tracking team did a great job capturing this one, climbing up the hill. So kudos to Adam, Pete, and Chuck. Keep an eye on the bird as it began to soar. Our thanks as well to channel member Callisti Lee for also a very generous $20 super chat, saying, fantastic coverage as always. Thank you, Will, the moderators, and all of Spaceflight Now for all you do to bring these launches to us. We appreciate you all so much. With a nice little heart for Valentine's Day. So thank you. It's been quite the saga for Intuitive Machines to get to this point, as they also had to make an adjustment on exactly where they were going to land as they were developing their plan and getting things ready for the mission. NASA decided to adjust the landing site of the Nova C lander to bring it down to the moon's south pole, as they decided that that would be a better spot to conduct the science using the suite of instruments that are on board the lander itself. And so now the spacecraft will spend the next several days making its way out to the moon, setting up for a touchdown on the moon's surface about 10 degrees north of the South Pole on February 22nd. As we continue to track the upper stage of the Falcon 9 rocket, staying with you until spacecraft separation and any preliminary checkouts. I want to thank a few more folks for their support this evening. James Sink with a $5 super chat, who says they just got off work and was driving south on US 1 towards Daytona Beach and saw the fireball in the sky, which is always fabulous as you're cruising down the road and get to see a launch just envelop right before your eyes. It says, thank you for covering the launch. You're very welcome. And thank you so much for supporting our coverage. I want to welcome our newest channel member, Mulder's Channel 24, joining us at the pad leader level. Really appreciate that and hope you enjoy the perks of channel membership, including discounts at our online shop, shop.spaceflightnow.com. Member-only videos here on the channel, as well as access to 4K views of all the launches that go up from the Cape. So we're about to bring in the telemetry data again. You'll see on the right-hand side of your screen, or we'll just bring it full frame. See, the spacecraft is cruising over the last little bit of the Atlantic before it passes over the western tip of Africa, continuing along its flight path in a nominal trajectory. We're just a little over 20 minutes away from that second stage engine burn. And for those who may not have been with us at the point at which we walked through the flight path to the moon for this Nova C lander, I want to go ahead and bring that in again. This was part of our conversation with Trent Martin, the Vice President of Space Systems for Intuitive Machines, talking about the path that this Nova C lander will take as it reaches the moon's surface.
Just after spacecraft set, about 90 seconds or so afterwards, we turn the vehicle on, acquire our first comm from the vehicle, figure out exactly what orientation we're in, and get into the right orientation. Within a few hours, we actually do an initial checkout of our rocket engine. We do a test fire in space with the rocket engine. We then do multiple trajectory chain burns to slightly update our trajectory on the way to the moon. Our operations team is in Houston in what we call our Nova Control. Nova Control is made up of a team of engineers and operations folks that have been instrumental in the development of the spacecraft, so they know the spacecraft intimately, to the point that if we see data, we're going to know exactly what is happening because we've seen it on the spacecraft when it was here on the ground. As we make adjustments along the way, we do a couple trajectory burns. We may or may not do those depending on whether or not we need them. You get to the point where you're just about to go into orbit around the moon. That one you can't miss. So you have to fire that one at just the right time so that you can go into a low lunar orbit at about 100 kilometers above the surface. We will stay in that orbit for about 24 hours, waiting for just the right moment where we can begin our burn to fire down to the surface. Once we begin that burn, we do not turn off the rocket engine. It stays lit the entire time all the way to the surface. We do have the ability to adjust the thrust on our vehicle, so we can actually throttle down from our 100% burn down to almost 20-25% of the overall thrust as we get closer and closer to the surface. Essentially, the spacecraft is just slowing down on its way down to the surface, slowing down, slowing down, slowing down. Just as we get to where we want to land, we do a maneuver where we pitch and go straight down, and we fire a rocket engine all the way down to the surface. Of course, our optical nav systems are looking, and this entire process happens autonomously. So the vehicle is looking down, it's comparing to known features that we're going to see on the moon, known craters or mountains or just features. And then as we get closer and closer, the system will take over that is looking for the safest landing site within the zone that we've picked. So we will identify the smoothest landing site and we'll land at that smoothest landing site. We obviously have a picked point, and if that site looks good, we'll land there. If not, we'll move to one of multiple sites nearby and land at that site. We land at about 1 meter per second. Once we touch down, the engine shuts off, the vehicle is safed. At some point, we actually vent out any remaining fuel, and then we're ready to begin operations.
Yeah, so quite a bit on tap for the Nova C lander as it gets ready to begin its multi-day mission on the moon's surface. Just a little over a week. It's expected to last before the lunar sunset, if you will. Future versions of the Intuitive Machines landers will be able to survive a lunar night, but with this first mission, they're mostly aiming to exact a successful landing on the moon's surface and allow the science payloads to perform as intended once they reach that point. Also on board the Nova C lander, as mentioned, there's 12 payloads in total, 6 of them from NASA. One of them actually coming from a group of students just up the road here on the Space Coast from Embry-Riddle Aeronautical University. It's a CubeSat called EagleCam. As the Nova C lander is making its descent down towards the moon's surface, it'll be ejected. It has a number of cameras on board the EagleCam, and it will take a third-person perspective of the landing as it happens. And we should be getting video or photos from EagleCam back about a day or so after the landing process actually happens. So look forward to that contribution from a hardworking group of students just up US 1 here on Florida's Atlantic coast. We're now T plus 25 minutes, 45 seconds and counting into this mission. Getting steadily towards the point of second stage engine ignition. That second burn coming up at T plus 41 minutes and 40 seconds. Before we get to that point, though, want to turn our attention to some of the stellar photography from our launch team. Actually, before we get to the photos, do want to note that the strong back is making its way back up here to a vertical position at the pad. Both NASA and SpaceX are going to be working quickly to get this pad turned around in preparation for a crewed launch heading up to the International Space Station. NASA's Crew 8, which is set to launch no earlier than the 28th of this month, with this quartet heading up to the ISS, led by NASA astronaut Matthew Dominic, second from the right there on your screen. Just to the right of that, you're seeing some onboard views from the Falcon 9 second stage. Now in the daylight as we've crossed past the Terminator. Getting some nice sunlight on board the Merlin vacuum engine. Turning back to the work of our launch photography team here. Want to bring in some of their photos from the launch this evening. This first one coming from our Adam Bernstein, pulling double duty as he was capturing some photos here as well as tracking the rocket itself. This moment of liftoff. Shooting from out in Orlando, These next photos coming from Michael Caine, about 45 miles away from Florida's Space Coast, over in more of the heart of Central Florida. This photo following the point of spacecraft separation as the boost back burn was getting underway. And close now with this image. A long exposure streak shot of both launch. You see spacecraft separation. And then the vertical streak of the booster coming back down towards landing zone 1 as well. So well done to our launch photography team, as well as our tracking team of Adam, Chuck, and Pete. We're now T plus 29 minutes, 41 seconds and counting. Now T plus 31 minutes, 33 seconds and counting. We are now right at 10 minutes away from that second stage engine ignition. This historic launch of the IM-1 mission, now poised to become the first American spacecraft to land on the moon's surface since Apollo 17 back in 1972. More than 50 years since an American craft set down on the moon's surface. Of course, Intuitive Machines has been able to watch a number of landers make attempts, some with varying degrees of success over the last year or so. Saw another commercial lander, couple commercial landers try and stumble, going back to the Hakuto R mission from iSpace in Japan, which made an unsuccessful landing attempt. Of course, the Peregrine Mission 1 Astrobotic, or lander from Astrobotic, that ran into a propulsion issue just a little bit after launch and spacecraft separation. There were certainly a couple of successes, though, with India's Chandrayaan-3, which set down on the moon's surface and had a successful mission there. And then you had the Japanese Aerospace Exploration Agency, JAXA's SLIM lander, which did touch down on the moon's surface, yes, safely, but it did tip over, allowing it to not perfectly be able to capture the sun's rays through its solar panels, and so it had to end its mission earlier than it was intending to. It was not able to complete all of its mission objectives. So, of course, Intuitive Machines is hoping to land closer to the Chandrayaan-3 end of the spectrum. T plus 34 minutes, 56 seconds and counting. A little under 7 minutes away from the second stage engine burn. No, T plus 37 minutes, 2 seconds and counting. So far, we've had 3 out of 4 planned launches leave their pads successfully. Of course, we're still very much in the midst of this mission, so go ahead and resist calling it a complete success at this point, but certainly the secondary mission of booster landing back at LZ-1 went off according to plan. And the second stage of the Falcon 9 rocket is continuing on a nominal trajectory, passing over the island of Madagascar. Of course, the one launch that did not go off as intended was the Starlink 7-14 mission out on the west coast at Vandenberg Space Force Base. SpaceX did not state a reason why they decided to scrub that launch as they pushed through the window, hoping to see that Falcon fly. Unfortunately, they were not able to get there. They're now targeting their backup launch opportunity tomorrow afternoon. We're now T plus 40 minutes, 30 seconds and counting. Coming up on a minute away from the second stage engine burn. These camera views from the onboard cameras. Falcon 9 second stage. The burn set to begin in now less than 20 seconds. It'll last a little less than a minute in total. See the Merlin vacuum engine roaring to life once again. Now coming up on the end of that burn, just a little over 10 seconds from now. You see the end of that burn. Now all that's left is
Nominal orbit insertion.
that call for nominal orbit insertion as the final step in this whole puzzle is for the Intuitive Machines Nova Sea lander to deploy T plus 48 minutes and 24 seconds. Just a little over 5 minutes away. Coming up on T plus 45 minutes into the count. Let's see the second stage passing over the Indian Ocean. Just over 3 minutes away from spacecraft separation. You can see now, taking a look back at Launch Complex 39A, the transporter erector fully upright. As NASA and SpaceX prepare for the launch of the Crew 8 astronauts and cosmonaut, coming up no earlier than February 28th. Now that the IM-1 mission has left the pad, should get a more finalized timeline of the Crew 8 pre-launch events probably in the coming days, up to and including when the crew is set to arrive here in Florida as part of their final phase of quarantine. And if in fact the launch is going to stick on the 28th, or because there was a one-day delay with the IM-1 mission, if that may slip slightly as well. Now, 47 minutes, 3 seconds and counting into the mission. Just a little over a minute away from deployment of the Intuitive Machines Nova-C lander. You can see that trajectory line charted away from our little blue marble. Video connection reestablished. Good timing as well, as we of course would like to see that lander separate from the spacecraft. We believe we're able to see this thanks to acquisition of signal from the tracking station located in Australia. And there's the lander. We see that now once again back on our screen. Earth beginning to fall away from the lander. And get some nice detail here. You see the American flag just underneath the Intuitive Machines logo.
IM-1, Odysseus Lunar Lander, separation confirmed.
And there you have it. The Odysseus Lunar Lander. Odie, now flying on its own odyssey, heading to the moon, hoping to be the first commercial lander to safely touch down on the moon's surface in history. An important and historic moment for the U.S. and, of course, for Intuitive Machines. At this point, the lander will begin to make its adjustments as teams on the ground acquire connection with it and prepare to orient the spacecraft to point its solar panels towards the sun, allow its batteries to charge and boot up, and do some of its initial checkouts. An important event comes up now 18 hours from now, as they'll perform the first initial burn of the engine powering the Nova Sea lander. That commissioning burn will tell Intuitive Machines that everything is on pace with this mission, and it is ready to send the spacecraft on its way to the moon.
Okay, copy. You're good to process in the background while we work contact.
Okay, I'll work with Fido on this.
Right now, we estimate that the lunar lander is traveling about 10 kilometers per second, which is about 24,600
All right, I want to make sure
miles
Com's
per
happy
hour.
with it. Com?
Standing by. I don't see packets updating in packet counts unless I'm looking in the wrong spot. And I'm not seeing anything populate in AOS.
So we're still standing by for autonomous commissioning and making that first ground communications from the lunar lander in space. We expect the carrier lock call to come from the comm or ground network stations inside of Nova Control. And this is Houston's first commanded lunar mission since Apollo 17.
All right, I see packets. And I see...
All right, guys.
And there we have it. We have packets. That is Michaela Landivar
All right, guys.
on the ground.
Com, I want your report. Uplink and downlink, what do we got?
Okay, so
We're
I'm seeing
seeing
packets
smiling
populate
faces
on
and
AOS
clapping
screen
there
in the
at
packet
Nova
counts
Control in
area.
Houston.
looks like telemetry is coming in pretty well. We have not started uplink, so
Teams are starting to get telemetry data from the Nova Sea lander
but
now.
It looks like we are seeing most everything that we would expect as far as
That's an
downlink is
excellent
concerned.
call. We have reached a
There is
pivotal
one thing
milestone.
Good
We're going to
process
bring
in
it
this
back
commissioning
into
sequence.
the broadcast booth and congratulate the team working inside of Nova.
And with the confirmation of some good initial checkouts from the Intuitive Machines team there in Houston, the mission seems to be hitting on all cylinders so far. So let's go ahead and begin to wrap up our live coverage, as we always do, with a look at where the mission stats stand for SpaceX and the greater launch industry. This was the 18th flight of a Falcon 9 booster 1061. This was SpaceX's 299th Falcon 9 launch to date, the 14th Falcon 9 launch of 2024. This was the 244th Falcon booster reflight, or the launch of a booster that has flown at least once. This was SpaceX's 14th orbital launch of 2024, the 100th orbital launch in the last 365 days, just the second time that SpaceX has hit this marker. Certainly not going to be the last, given their flight cadence expected in 2024. This was the 75th SpaceX orbital launch from this pad, 39A, and the 168th overall orbital launch from this particular pad. Now, where things stand, this was SpaceX's 14th launch of this calendar year, continuing to move on up. Moving on to recoveries, this was the 37th landing at Landing Zone 1, LZ1, the 47th SpaceX land landing in Florida when you combine the pair of them. Bringing in California, this was the 62nd overall land landing and the 273rd overall SpaceX booster landing to date, including the drone ships. And finally, moving out to the industry as a whole, this was the 10th orbital launch from the state of Florida, the 15th from U.S. soil, the 16th from a U.S. rocket company, including Rocket Lab's launch from New Zealand, and the 30th orbital launch globally on the year, as we did have a Russian Soyuz launch just a few hours ago. Bringing it out to our pie chart overview. Actually, Stephen, if we can bring down the box there, just so we can see Russia. Thank you. So 16 launches for the U.S., still continuing to dominate on the global stage. China, second with 27% of the orbital launch piece of the pie. Russia and Iran now each have 2 launches on the year, with Japan and India each with one apiece. Although we know Japan is getting ready to launch its H3 rocket on its second test flight. That's coming up in just a couple of days. So we'll look forward to hopefully seeing a more successful launch campaign for Japan and JAXA with that. And with that, we're going to go ahead and wind our coverage down. We really appreciate everyone joining us for a lot of engaging coverage this evening, talking about a historic mission now well on its way to the moon. First off, I want to thank all of our wonderful moderators for helping us out in the live chat. Astro Joe, coming in strong there. As well as I thought I saw Stephanie B at one point. I want to thank our launch coverage team of Pete Carsons with Max Q Productions, as well as Chuck Briggs. Also our team here on the ground are Adam Bernstein, Michael Kane, both coming in with some great launch photography. Be sure to keep up with their handles on X if you'd like to see more from them. And you can also follow me as well. And of course, we'll be looking forward to this site coming up on February 22nd is when the target landing for the Intuitive Machines lander will happen. And while it may not exactly look perfectly like this, we will actually get to see, if all goes according to plan, something similar to this as the Embry-Riddle Eagle Cam will be ejected and get third-party perspective of Intuitive Machines lander on the moon's surface. So very much looking forward to that and all the views, as that process is going to be live streamed, and you can bet that we'll have coverage on that as it happens. Also want to thank our editor here at Spaceflight Now, Stephen Young, for running the technical aspects of the broadcast. Lots to track with this mission over the next several days. So be sure to stay with Spaceflight Now, both here on YouTube as well as on our website, spaceflightnow.com. And of course, with the pivot away from a launch yesterday of the Starlink 7-14 mission, SpaceX now targeting 1:34 p.m. Pacific, 4:34 p.m. Eastern, 21:34 UTC tomorrow for the launch of that mission. And assuming SpaceX moves forward with that launch plan, we'll have live coverage here on YouTube as well. And last but not least, there's been a lot of space news happening this week. And you know we're going to be covering it, all the big launch stories, on our weekly live show, News from the Press site, coming at you on Friday afternoon. We'll be going live at 4 p.m. Eastern on Friday, so we hope to see you there. We'll have our guest announcement coming up tomorrow afternoon, so be sure to follow Spaceflight Now on Threads and Twitter so you get notified of who our panelists will be to discuss a roundup of the big space beat stories that we've had this week, and there have been quite a few of them, up to and including, of course, this historic launch that we all witnessed here tonight. Most important, want to thank you for spending part of your Wednesday night now into Thursday morning on a very busy day of live launch coverage with 4 missions that we were tracking between USSF 124, the attempted launch of the Starlink 7-14 mission, the launch of the Progress vehicle heading toward the ISS, and finally a successful flight of of Intuitive Machines Nova Sea lander. It's been a long day. Let's go ahead and button this up. Thanks for being with us. For all of us here at Spaceflight Now, I'm Will Robinson Smith. Let's all get a good night's rest, or hope you have a good morning if it is early for you when you're just getting your day started. I hope it's a great one. Most importantly, be sure to be good to yourself, be good to others, and we will see you next time. Good night.